Have you ever read a news headline, maybe about a big environmental cleanup,
Yeah.
or seen a public health notice about air quality in your city,
Mhm.
and found yourself wondering, okay, how do they actually do that, beyond the press release?
Right. What are the actual steps involved?
Exactly. What are the detailed scientific operations happening behind the scenes, the ones protecting us and our environment? It's definitely not magic.
No, it's meticulous science, a lot of it.
So today, we're taking a deep dive into exactly that hidden complexity. Our source material is a statement of work in SOW for the U.S. Environmental Protection Agency's Environmental Services Assistance Team. That's ESAT.
Right, ESA. This one's specifically for regions 8, 9, and 10 out west.
Think of this document as, well, an incredibly detailed blueprint. It reveals this astonishing range of technical, analytical, and quality assurance support that's needed.
Yeah, support to identify, assess, regulate, and ultimately remediate environmental hazards. It's comprehensive.
And our mission here is to unpack this dense document for you. We want to extract the surprising facts, the crucial insights.
Think of it as a real behind-the-scenes look.
Yeah, how environmental protection really works on the ground. We'll connect some obscure operational details to their, frankly, monumental impact.
Often life-saving impact.
Absolutely. We're going to explore the 6 core task areas that make up this vital work. Okay, so let's get started. What exactly is ESAT, and why is this contract, this specific one, so critical for the EPA in these regions?
Well, at its core, ESAT provides specialized support, technical, analytical, and quality assurance support. That's the main thing.
Okay.
If you connect that to the bigger picture, the EPA needs robust, really reliable information. They use it to make critical administrative decisions, regulatory ones, decisions about human health,
Yeah.
all related to environmental hazards.
So this contract helps them get that reliable info.
Exactly. It optimizes how they use their regional laboratory facilities. It ensures the EPA has the scientific muscle it needs, basically when and where it needs it.
So help us understand, what kind of environmental threats are we really talking about here? And what big laws does this support? What's the sort of scope?
Well, the support ESAT provides is critical across a really wide spectrum of environmental challenges, a very wide spectrum.
Like what, for instance?
For instance, it's absolutely necessary for implementing major environmental laws. Think CERCLA.
Super fun, right?
That's the one. Super fun. Also, the Clean Water Act, the Clean Air Act, Safe Drinking Water Act, RCRA, Resource Conservation and Recovery Act.
Okay, so the big ones.
The big ones, yeah. And others too, like TSCA and FIFRA. But what's truly fascinating, I think, is that its scope even extends beyond that.
How so?
It includes assisting other federal agencies in counterterrorism efforts,
Really? Counterterrorism?
specifically in identifying and remediating environmental hazards, maybe after an event, as required by the national response plans.
Wow, that sounds like a massive undertaking then.
Mhm.
Almost like a scientific rapid response team for anything environmentally dangerous.
That's a pretty good way to put it. From everyday hazardous waste sites to, yeah, potentially more sinister events.
Okay, let's dive into task area I. This seems to be where the hands-on science really happens. Analytical support. This sounds like the engine of the whole operation. What kinds of things are they analyzing? What tools are they using?
Yeah, this task area covers extensive chemical, biological, and field analysis. The sheer variety of samples is pretty astounding.
Like,
Everything from dust, air, water, to soil, tissue samples, even tricky stuff like dense non-aqueous phase liquids, DNAPLs, and non-aqueous phase liquids, NAPLs, oily contaminants.
and where did these samples come from?
All sorts of places. Known hazardous waste sites, sudden spill events, or, as we mentioned, even potential terrorism events.
Oh.
So yeah, they could contain highly hazardous materials.
That raises a pretty important question then. When you're dealing with stuff that dangerous and so varied, what kind of tech are we talking about? What do these labs actually look like?
Right, they need sophisticated technology. For organic compounds, they're using techniques like GCMS, gas chromatography mass spectrometry,
Okay.
and even higher resolution versions like HRGCHRMS. For inorganic elements, metals and such, you're looking at ICP-MS, inductively coupled plasma mass spectrometry, and things like direct mercury analyzers, DMAs. They even do microscopic detection of asbestos fibers.
Wow.
These are really the workhorses. They can identify incredibly small concentrations of contaminants.
How small are we talking?
We're talking parts per billion, sometimes even parts per trillion. It's like detecting a few drops of something in an Olympic swimming pool.
That level of precision. Why is that so vital?
Because even tiny trace amounts of certain chemicals can pose significant health risks over time or to sensitive ecosystems, so you have to be able to find them.
And it's not just chemicals, right? The SOW mentions biological support. What does that involve?
Yeah, that's a crucial component, too. It includes biological testing on hazardous waste, water, soil, tissues.
Testing for what?
They use things like aquatic and sediment toxicity tests, basically seeing if the water or sediment is harmful to organisms living there. Bioaccumulation studies, too.
Tracking how toxins build up.
Exactly. Build up in the food chain. And even microbial and viral assessments looking for pathogens.
And how do they get these biological samples?
Sometimes they need specialized collection methods, like electrofishing, which temporarily stuns fish so they can be collected safely.
Okay.
Or even dive support, which means trained divers going into potentially hazardous waters. That requires specific EPA dive training and really strict safety protocols.
So it's a whole ecosystem health check, not just chemistry.
Precisely. A comprehensive look.
Okay, so they're busy in the lab. What about out in the field? The document mentions field assessment, analytical and/or sampling support. What's the real-world application there? Especially when time might be critical.
Think mobile labs. Actual laboratories in trucks or trailers deployed directly to a site, sometimes for emergencies.
So they can get results faster.
Much faster. Rapid turnaround analyses using portable instruments, things like X-ray fluorescence, XRF for metals screening, or advanced methods like laser-induced fluorescence, getting data right there on the spot.
And the people doing this work need special training.
Absolutely critical training, like the 40-hour HAZWOPER training hazardous waste operations and emergency response. It's essential for safety when working on hazardous sites.
And what are they doing out there with this training and equipment?
Conducting crucial site inspections, Superfund site assessments, even implementing what are called dynamic sampling plans.
Dynamic, what does that mean?
It means the sampling plan can adapt in real time. As they get new data on site, they can adjust where they sample next, making the investigation more efficient and effective.
Okay, got it. And you mentioned air quality earlier.
Yeah.
How involved are they with that, our air?
Yes, a significant portion of this work supports the EPA's Office of Air Quality Planning and Standards, OAQPS.
Doing what specifically?
Performing evaluations on the ambient air monitoring instruments, the ones that track particulates like PM2.5, those really fine particles that affect lung health, and PM10 2.5, and also the criteria gases, common pollutants like ozone, carbon monoxide, and lead.
So they're checking the checkers.
In a way, yes. They audit major monitoring networks, too, like the PM2.5 Chemical Speciation Network and IMPROVE. These are key national systems providing the air quality data we see reported.
And they have to follow strict rules for that.
Very specific federal regulations and standard operating procedures, SOPs. It has to be incredibly consistent and reliable.
It's clear getting the data is one thing.
Yeah.
But all this sophisticated equipment, managing the samples, that sounds like a huge job in itself. What about field warehouse operations support and laboratory support functions?
Right. These are the crucial background operations, often unseen, but they underpin everything.
How so?
Well, how do you make sure all this complex field equipment is ready to go at a moment's notice? That's the field warehouse team. They manage requests, calibrate instruments, maintain them, repair them, ensuring everything is in a ready state for deployment.
And in the labs?
Lab support includes routine instrument setup and maintenance, meticulous glassware washing, often with strong acids and bases to avoid any cross-contamination.
Right. Can't have residue messing up the next sample.
Absolutely not. And then there are critical sample custodial duties, logging samples imprecisely, entering data into LIMS laboratory information management systems,
That is so
and managing the proper safe disposal of analyzed hazardous waste. Without this foundational work, the high-quality science just wouldn't happen.
Okay, so that's task area 1. A lot going on there. Now, once all these samples are collected, analyzed, what happens next? Task area 2 is data review. This sounds critical. Why is this step so important for trusting the data?
Data review is paramount, absolutely paramount, because it rigorously assesses the quality and completeness of all that analytical data.
Data from where? Just EPA labs?
From various sources. EPA labs, yes, but also labs run by potentially responsible parties, PRPs.
The polluters themselves, maybe?
Potentially, yes. So the scrutiny has to be intense. It includes rigorous data validation, meaning they cross-reference results, check for any inconsistencies, confirm that samples were collected and analyzed according to the highest scientific standards following the established plans.
You don't end up making decisions based on bad data.
Exactly. You can't have faulty data leading someone to declare a site clean when it still poses a risk, for example. It's all about building absolute trust in the information that drives these critical environmental decisions.
Okay, that makes sense. Then there's collection and tabulation of data. This sounds like making sense of it all.
That's right. They produce statistical reports. They quantify how many data points might have been rejected during review or maybe estimated, and explain why.
So turning numbers into understanding.
Pretty much. It involves entering and managing all this data in automated systems and databases, sometimes using complex programming languages like SQL or PERL or Python to handle large data sets.
Transforming raw numbers into clear, actionable insights that policymakers can actually use.
That's the goal.
And then we move to task area 3, analytical logistical support. You called this the central nervous system earlier.
Yeah, I think that fits.
It sounds like coordinating everything.
Yeah.
What's the biggest challenge there, keeping all those moving parts aligned?
It truly is like a central nervous system. This task area is all about managing the immense flow of analytical data and all the related documents.
What does that involve day to day?
Tracking sample analyses, projections, knowing what's coming. Inventorying data packages as they arrive. Handling all the ins and outs of the samples themselves. From tracking them, making sure they're packaged correctly, shipping them securely, and then distributing the final data packages to the data validators we just talked about.
So managing the whole life cycle of a sample and its data?
Exactly. They use specific EPA-developed software, like Scribe, for really precise sample tracking. Chain of custody is vital.
And they even handle IT.
They can, yeah. Provide IT support for lab systems, databases, even data visualizations. It's that behind-the-scenes magic, keeping thousands, maybe millions, of data points organized, secure, and accessible, ensuring the right information gets to the right people at the right time for those environmental decisions.
Okay, moving on to task areas POO and V. These seem focused on quality and continuous improvement. Task V is QA/QC support.
Quality assurance, quality control, yes.
So for you listening, this is all about ensuring the integrity and reliability of the environmental data and the assessments that impact public safety. What are some key areas here?
This task area is really about ensuring every decision made is based on unimpeachable science, solid science. It includes preparing and reviewing critical assessments. Things like ecological risk assessments, how might this hazard affect plants and animals, and human health risk assessments, what's the potential harm to people, biodiversity assessments, analyzing groundwater hydrology data.
Why groundwater?
To predict precisely how contaminants might move through the environment underground, which communities or ecosystems could be affected down the line. These assessments directly inform cleanup levels and protective measures.
And I see mapping as a big part of that too, with Geographic Information Services, GIS.
Yes, absolutely. Using commercially available GIS software, like ESRI's ArcGIS, they provide extensive geospatial support.
What does that let them do?
It allows for data development, spatial analysis, cartographic support, basically visualizing complex environmental information.
Like drawing maps of contamination.
Exactly. Mapping pollutant plumes spreading underground or identifying critical habitats for endangered species that might be threatened. It's crucial for understanding where the hazards are, how they might spread, and what areas need priority protection.
Makes sense. They also prepare and review QA project plans. QAPPs. What's the significance of those?
QAKPs. And SAP sampling and analysis plans. These are the scientific blueprints for all data collection activities.
Blueprints.
Yes. They meticulously outline the project's goals, what decision needs to be made. What are the specific sampling variables? What methods will be used? How will uncertainty be analyzed?
So, planning out the science in advance.
Critically important planning. This support ensures all data collected adheres to the very stringent EPA quality system guidelines. You have to ask, how could you possibly trust environmental data without these incredibly rigorous plans in place first? You couldn't.
It sounds like they have to keep learning and adapting too. There's development and/or review analytical methodologies and attendance at specialized technical training.
Absolutely. Environmental science is constantly evolving. New threats emerge. Better detection methods are developed.
So they need to stay current.
Constantly. The contractor provides essential technical support here, developing and refining analytical methods, updating standard operating procedures, SOPs. They research new techniques, they revise existing ones, just making sure the EPA always has the most effective tools in its toolbox.
And the training.
Continuous training is key. On EPA-specific software, new analytical instruments, field safety protocols, it ensures the team stays cutting edge and prepared for literally any challenge.
And finally, under other task-related activities in this section, they implement their own quality assurance program. Why is that internal check important?
It demonstrates their deep commitment to consistent, high-quality work across the board. They're required to implement a quality assurance program according to their own detailed quality management plan, or QMP, and specific QAPPs for each region they serve.
So they're checking themselves.
Yes.
Oh.
It ensures they meet or even exceed the EPA's stringent requirements for everything they do. It also includes detailed tracking and reporting of costs and progress. It's an internal check designed to guarantee the external checks are flawless.
Okay, one final area. Task Area 6, External Regional Laboratory Analyses. What happens if the EPA's own labs, even with all this ESAT support, can't handle a specific analysis? Maybe it's too specialized or they're just overloaded.
That's exactly what this task area addresses. The contractor is tasked with finding qualified external analytical laboratories to perform those specialized analyses.
So outsourcing.
Well, yes, but with extremely rigorous oversight. That's the fascinating part here.
How so?
The contractor must ensure that any subcontracted lab meets all the necessary quality control and regulatory requirements. Every single one. And crucially, the EPA retains the ultimate right to accept or reject any lab the contractor proposes.
So it's definitely not just send it out and forget it.
Not at all. It's about carefully extending the EPA's analytical reach while maintaining absolute control over data quality, which is vital for protecting public health. You can't afford unreliable data slipping through.
And there are strict data standards for these external labs too, right?
Precisely. For any analytical services procured through these subcontracted labs, the data must be reported using specific, standardized electronic formats. Like the ERLN-EDD, that's the Environmental Response Laboratory Network Electronic Data Deliverable, or the SEDD, Staged Electronic Data Deliverable formats.
Why the specific formats?
It's critical because it ensures seamless integration and analysis across different labs and different EPA programs, especially for huge initiatives like the Superfund program. Under Superfund, all analytical services have to be meticulously tracked and reported electronically in these standard ways. It ensures that no matter where the analysis actually happens, the data is trustworthy and can be easily incorporated into the national systems for comparison and decision-making.
Wow. We've just taken a deep dive into really just one government contract. And it's truly incredible to see the meticulous, multifaceted work that's required behind the scenes. All to protect human health and the environment. It's definitely not just headlines.
No, it's a vast, interconnected web. Scientific analysis, precise logistical coordination, and just this unwavering commitment to quality at every single step.
This deep dive really shows you, doesn't it, that behind every environmental regulation you hear about, or every cleanup effort,
there's an immense amount of scientific rigor and operational detail, just layers upon layers of it.
It's a powerful reminder, I think, that knowledge is most valuable when it's actually understood and applied.
And that critical thinking is so essential, especially in a world overflowing with information, particularly when it concerns the air we breathe, the water we drink, the land we live on.
So what stands out to you most from digging into this SOW? Maybe it's the sheer range of scientific tools they use?
That's definitely impressive.
Or the incredible precision needed, detecting contaminants at minuscule levels?
That too. Or maybe even the logistical complexity, just managing thousands of samples from all these different sites.
Yeah, the coordination is mind-boggling. So here's a final thought for you to consider. Given this immense, often unseen dedication to detail in environmental protection, what other hidden layers of complexity might exist behind other seemingly simple government initiatives? And how does this level of meticulous oversight ultimately safeguard us all in ways we probably rarely even consider in our daily lives?